feeling overwhelmed by information. Ever wish you had like a secret weapon for understanding complex topics quickly?
Hmm.
Today, we're diving deep into something that might just be that weapon. Multirelational semantic maps. You might also know them as knowledge maps or concept maps.
Yeah, and our mission on this deep dive is pretty clear. We
Yeah.
want to explore what these maps are, where they came from, how they work,
Yeah.
and really why they could be such a powerful tool.
Especially for quickly grasping new information, right? Tailored for you, the learner.
Exactly.
We've been diving into this foundational academic paper actually from way back in 1989.
Yeah, it's fascinating.
It really is. It lays out the promise of these mapping systems and, what the research looked like back then.
Mhm.
And since you told us you're keen on gaining knowledge efficiently, avoiding that information overload, well, this deep dive should give you a solid handle on these maps.
Without getting totally bogged down in jargon, hopefully.
Yeah, let's try. Okay, let's unpack this. What exactly are these multi-relational semantic maps?
Okay, so think of them as two-dimensional visual blueprints for knowledge, basically.
Blueprints? Okay.
You've got concepts represented as points or nodes, right?
Okay.
And then lines or links connecting them to show how they relate to each other. The multi-relational bit is really key here.
How so?
Well, a single concept isn't just stuck with one type of connection. It can have, all sorts of different relationships with other ideas on the same map.
Okay, that sounds really practical. I mean, we see visuals all the time, right? City maps, flowcharts, spreadsheets. What makes these semantic maps different?
That's a great point. And yeah, while those other visuals definitely have their specific uses, semantic maps are aiming for something broader.
Broader. How?
Well, a roadmap shows you, quantitative spatial stuff. A flowchart outlines steps in a process. A family tree shows hierarchies.
Yay.
Tables are great for data, but showing really complex, varied relationships. Not really their strong suit. Semantic maps try for the kind of flexibility you get with, like, natural language. You can express all sorts of connections, but visually. They don't just show that things are connected, but how, and hopefully in a really clear way.
So instead of just seeing a list of terms, you actually see the web of connections between them.
Precisely. And even back in '89, these researchers saw the potential for these maps to, enhance or even replace things like textbooks, study guides, lectures even.
Wow.
And they also saw them as powerful tools for students, for learning, for thinking through ideas, even for, organizing thoughts before writing.
The paper mentions figure 1, showing different types of these links. What kind of relationships are we actually talking about here?
Yeah, figure 1 gives you a good sense of the richness. They used links like dynamic influences. That's for cause and effect, basically, how one thing impacts another.
Okay, like A leads to B.
Sort of, yeah. Then there's next leads to, which is perfect for sequences or processing.
Right.
Static type indicates a category, like saying a poodle is a type of dog. Actually, their example is dog poodle with a question mark.
Oh, interesting. Why the question mark, do you think?
Good question. Maybe highlighting it's just one example, or perhaps it's a less common or obvious one. Not entirely sure from just that snippet.
Okay. And I see the arrow showing direction. What other kinds of connections did they have?
Oh, quite a few. Part shows components like fingers are part of a hand. Their example is hand NEGEs.
Got it.
Then characteristic for describing features like JRFLT, Daje, eulogene, eyes. There's even instructional analogy, which is fascinating.
Analogy. How does that work on a map?
It's about relating a new idea to something familiar. Like their example, a river, time, connecting it to the concept of flow, making the abstract more concrete.
That's clever.
Yeah. And they also had simple example and comment links just for adding detail or explanation. It really shows how nuanced these connections can be.
It does. So it's not just saying these are related, it's forcing you to think how they're related.
Exactly.
Yeah.
Which should lead to a more precise understanding, right?
Absolutely. Like having a whole toolbox of relationship verbs. Okay, so the paper then dives into something called the TCU Knowledge Mapping System. What was special about that one?
Right, the TCU system. Developed by these researchers, it was a real attempt to create a more structured and comprehensive way of building and using these knowledge maps.
Structured.
Yeah. Figure 2 gives the big picture. It shows it has both structural elements, the nuts and bolts of the map itself, and dynamic properties, how you actually make and use the maps.
Okay, so let's look at that specific example, the TCU system.
Let's start with the structure, the structural properties.
Makes sense. What are the main building blocks of a TCU map?
Well, there are 4 key structural bits. links, nodes, spatial configurations, and map unit formats.
Okay, links, nodes, spatial configuration, map unit formats.
Got it. We've touched on links, but the TCU system really emphasizes them. Figure 3 goes into the details. They use named links with abbreviated labels, all drawn from a standard set.
A canonical set, they called it.
Exactly. Think of it like having a limited but really useful set of verbs for describing relationships. Makes talking about the map clearer, more efficient.
Okay, but why bother with a standard set? Why not just write down whatever relationship you think of?
Good question. The researchers argued these systematic named links really boost the whole process.
How so?
For the map creator, these labels act like prompts. They guide you to think more deeply about all the possible connections. They call this relationship-guided search.
Relationship-guided search.
Okay. You start with an idea and ask, okay, what kind of characteristics does it have? What does it lead to? What types of things are included? What are its parts? And so on. Helps build a much more thorough map.
Ah, I see.
And for someone reading the map, these named links clear up a lot of potential confusion about how ideas are connected. Makes it easier to understand and find specific info.
That makes total sense, like a shared language for relationships. What else was important about the links in this TCU system?
They also use link modifiers like a plus, a minus, and a question mark to add precision.
For nuance.
Yeah, especially in complex areas. You might need to show positive versus negative effects or indicate uncertainty. Plus, they used arrowheads, really clearly showing directionality and, potential pathways for processing the info.
Right, answers that where do I start question.
Exactly. And the lines themselves could tell you something too, right?
Yeah, different categories of links, like dynamic relationships might have different line styles, like a barbed line instead of a solid one.
Oh.
The idea is to help someone quickly spot broad categories of connections. They mentioned other options like color and thickness, but also warned against, visual overload, right? You don't want the map to be harder to read than the actual topics.
That's nicely.
Okay, so that's links. What about the nodes? What do they look like? What info do they hold in the TCU system?
Figure 4 covers the nodes. Their visual aspects like the border style, shape, color could signal importance or content type.
Ah, visual cues.
Yeah. Most nodes have text key ideas, short statements, but they could also hold pictures, formulas, symbols. And the TCU system had special nodes too for things like placekeeping, encoding, pointing, kind of like headings and references in a text.
So extra info at a glance from the node itself.
Exactly. Then you got spatial configurations. Figure 5 illustrates this. It's all about how you arrange the nodes and links on the page.
The layout.
Right. And the TCU system deliberately uses Gestalt principles. These are basically visual tricks your brain uses to organize things.
Gestalt. Sounds a bit academic. Can you give an example?
Sure.
Fact.
Grouping similar things together using symmetry, continuation, parallelism. These visually organize the subject matter, make it easier to find related subcategories.
Okay, so if I have several concepts that are all, say, examples of a main idea.
You might arrange them symmetrically around that main idea node, maybe use the same shape or color for all of them. That visual similarity in arrangement immediately tells your brain, hey, these belong together, similar relationship. Or if you're mapping a process, steps happening one after another, you'd arrange the nodes in a clear line or path, using that principle of continuation to visually emphasize the sequence.
Okay.
Even breaks or gaps in these patterns can highlight areas where maybe more info is needed. Basically, the layout isn't random. It's designed to leverage how your brain naturally sees patterns. Makes it easier to navigate and remember.
Using our visual processing power to understand the structure. Makes sense.
Exactly. And the TCU system also uses knowledge prototypes. Think of these like common templates for organizing information.
Templates.
Yeah, figure 6 gives examples. Descriptive hierarchies like a family tree showing categories. Logic or action chains like a recipe showing steps. Concept clusters, groups of related ideas. And the way the links and nodes look can be adjusted to highlight these underlying structures. So the overall organization of the topic becomes more obvious.
So if it's step-by-step process, the map might look sequential. If it's a classification, it might look more like a branching tree.
Correct. And finally, the fourth structural bit, map unit formats. Figure 7 describes this. It's about the scope and size of the maps.
Like chapters in a book.
Kinda, yeah. Or modules in a course. The TCU system allows for either single, large, comprehensive maps, or a hierarchical set of smaller maps linked together.
One big map versus several smaller ones. Pros and cons.
Well, a big map gives you that fantastic overview, right? See connections between distant parts. But they can get complex. overwhelming even, which can actually hinder learning.
Yeah, I can see that.
On the other hand, a set of smaller linked maps, like insets on a geographical map, can be easier to navigate and digest. The TCU folks even talked about a map sandwich,
A map sandwich, yeah.
an overview map linking to detailed maps, which then link to a summary or review map.
Ah, overview, detail, summary, like a book structure again.
Exactly.
Yeah.
Smaller maps are often more practical for display, maybe easier to process and remember initially. It's a trade-off, really,
Yeah.
seeing the whole landscape versus managing the detail.
Okay, that covers the structure. Now, what about the dynamic properties? How are these TCU maps actually made and used?
Right, the dynamic side. The researchers admitted back in '89 they still had limited real-world experience with using these maps. So a lot of their ideas about how to create them were based on what seemed logical, a face validity, they called it.
Okay.
They outlined two main ways to produce a map, shown in Figure 8, top-down and bottom-up.
Top-down, sounds like you start with the big picture.
Pretty much. With a top-down approach, the map creator needs a pretty good existing knowledge of the topic already.
Makes sense.
They start by deciding the overall structure of that knowledge prototype right away.
Yeah.
Once they have the framework and main concepts, they use that relationship-guided search we talked about.
Using the link types to find details.
Right, to actively look for and incorporate relevant details. Finally, they organize everything using those Gestalt principles, fine-tune the visual appearance. This method is generally best for experts, instructors, or students who already have a solid grasp of the subject.
Okay. And bottom-up is for newcomers.
Exactly. Someone just starting out might begin with only a few key ideas, then use that relationship-guided search to gradually expand the map outwards.
Growing it piece by piece.
Yeah. As the map grows, the creator tries to identify a useful structure, the knowledge prototype that emerges from the content itself. Then they reorganize, add details, refine using Gestalt principles, visual cues.
Ah, letting the structure reveal itself.
Kinda, yeah. And just like top-down, the final map could be one big one or a set of linked smaller ones.
Makes sense. What about once a map exists, how do you actually use it to learn?
First crucial step, they say, is get familiar with the map's conventions. Understand what the different links, nodes, spatial arrangements mean.
Learn the language of the map.
Exactly. Then, when looking at it, they recommend scanning the whole thing first. Get a general overview, look for patterns, symmetries, gaps, highlighted info.
Get the lay of the land.
Right. Try to identify the underlying knowledge prototype hierarchy, process, argument. That helps figure out the best way to approach it, how to allocate study time. If you're not sure where to start, reading top to bottom, left to right, mentally translating it into your own words, even adding your own annotations can be really helpful.
Active engagement, not just passive viewing.
Totally. And sometimes trying to form a mental image of the spatial organization can help with recall later.
Interesting. Okay, the paper then talks about a taxonomy of map devices, arguing all maps use three main ways to show relationships visually. What are those three?
Those three fundamentals are spatial arrangement on the page, the characteristics of the nodes, and the types of links used.
Layout, nodes, links?
Yep. And the researchers suggest the more intentionally a map maker uses these, the more computationally efficient the map will be.
Computationally efficient, meaning easier for your brain to process.
Basically, yeah, how quickly and easily your brain can find and understand the info. A well-designed map minimizes the mental effort needed. Figures 9 through 13 show different styles based on which device they rely on most.
So some maps mainly use just where things are positioned.
Yeah, these spatially based maps, like in Figure 9, they imply relationships just by grouping related words or phrases close together.
Like an outline.
Exactly.
Yeah.
Headings or dividing lines might add structure, but proximity is the main thing. Similar to traditional outlines or simple tables. Easy to create, maybe, but not ideal for complex topics with lots of different kinds of relationships.
Why not?
Because it's hard to show all those different connections simultaneously just using space without making it super confusing. Figures 10 and 11 show this same info in a table, but emphasizing different aspects makes them look quite different.
Right. Then there are maps focusing on the nodes themselves, making them look different.
Exactly. Node-based systems, like in Figure 12, use variations in node appearance shape, border style to indicate different relationship types. Links, if used, mostly just connect the nodes without specifying the connection's nature.
What's the limitation there?
It can be hard to show the specific nature of the relationships, like how different structural features relate to different functions or categories.
Okay. And link-based systems are all about the connections.
Precisely. In a link-based system, shown in Figure 13, the links are the stars. They connect uniform nodes, Sometimes there aren't even explicit node, just labeled connections, and clearly specify the relationship.
Overcoming the limits of the other two.
When it comes to showing multiple diverse relationships, yes, the links themselves can look different or have labels, either specific to that map or from a standard set.
And the TCU system, as a hybrid map in Figure 14, brings all three together.
Yes, true. Hybrid maps strategically use spatial arrangement, different node types, and various link styles and labels. The idea is more visual cues mean less guesswork needed to understand the relationships.
Makes sense.
But, as we said earlier, risk of visual overload. Too much information.
No.
That's where the map sandwich overview plus detail maps might be really useful for complex stuff.
It's a balancing act. Clarity versus clutter.
Exactly.
Okay, the paper then shifts focus. Looking at the research done on using these maps in education, what were some of the early influences here?
Well, the researchers point to the long history of things like flowcharts and organizational charts in business and engineering. Early forms of visual knowledge representation.
Right, those have been around.
More recently, semantic networks in computer science and cognitive psychology, especially Quillian's work on memory as a network of concepts, provided a theoretical basis.
Thinking about knowledge visually.
Yeah. And they also mentioned connections to psychological models of propositional structures, which you can represent as node link networks. So it wasn't a totally new idea. It built on existing ways of visualizing information.
So it had roots. What did the early educational research show about how effective these maps were?
They looked at a wide range of studies, found reports of success in various settings, college down to elementary school, diverse students, lots of subjects like reading, science, math, history.
Sounds promising.
It did. But for their review, they focused specifically on studies where the map was used to convey info from teacher to student, or to help the student learn. Not studies analyzing how a student's knowledge structure changed over time.
Okay. The paper discusses graphic organizers for reading comprehension. What are those and how are they used?
Graphic organizers in reading research came from Osbel's work on advanced organizers, tools to help learners make sense of new info by activating prior knowledge.
Setting the stage for learning.
Exactly. These maps, often without labeled links, were used before reading to intro vocab or activate background knowledge, help make predictions.
And after reading.
Used to reinforce vocab, summarize main points, compare-contrast ideas, start discussions. But the researchers noted a meta-analysis by Moore and Reedens found only small to moderate positive effects on comprehension.
Only small to moderate. Why might that be?
Possibly because the lack of clear labels on the links made the relationships less explicit, less helpful than they could have been.
That makes sense. If you don't clearly state the connection. What about when students made the maps themselves? Any benefits there?
Studies on student-generated maps explored several advantages, yeah. One was as a learning strategy for complex info, seemed to lead to better understanding. Some suggested using closed tasks, filling in missing parts of a map for review or diagnosing problems.
Like a fill-in-the-blanks map.
Kind of. Another use was pre-writing. Some research suggested it led to longer, more coherent, better organized essays.
Interesting.
Mapping was also seen as good for brainstorming, externalizing thoughts, maybe sparking creativity. Buzan's mind maps are mentioned as an example of this more free-form approach.
Ah, mind maps.
Yeah. And there's even a mention of the idea that representing concepts visually might actually change how you think about them. A bit like the Sapir-Whorf idea, but visually.
Wow.
These activities could be individual or group work, usually paper and pencil, chalkboard, but increasingly computer software even back then.
So actively making the map seems beneficial.
It appears so, yes. More than just being given one, perhaps.
What about when teachers made maps? What was the rationale there?
Teachers who made maps said it helped them understand the subject matter nuances better, identify potential student difficulties, also useful for organizing lectures and lesson plans.
Okay. Now, the paper really highlights Novak's concept mapping system, a significant contribution. How does that compare to the TCU system?
Novak's work is definitely a major landmark. His system focuses on propositions, concept relationship, concept units.
Okay.
He also introduced rubber maps, showing multiple perspectives. But there are key differences from TCU.
Such as?
Novak's maps are always hierarchical. TCU allows non-hierarchical maps, better for processes or comparisons.
Right.
Novak uses arrowheads only when a subordinate node isn't directly below, relying on spatial position for direction. Can reduce clutter, but limits structure. And Novak's link labels tend to be more idiosyncratic, specific to the map. TCU aimed for that standardized canonical set.
different philosophies there. What was Novak's main focus?
Primarily evaluation diagnosing student understanding based on Ausubel's learning theory and instructional planning. He even scored maps, and famously used them for planning a complex interdisciplinary seminar. Really showcased educators taking a central role via mapping.
Feels like really enthusiastic work, showing lots of possibilities. Definitely. But the paper also points out limitations in the research generally, and even in Novak's work. What were those criticisms?
Well, across the field, except maybe TCU and Novak, it was a bit of a haphazard collection of approaches. Not always strong theoretical foundations.
Methodologically weak.
Often, yeah.
Yeah.
Issues with defining variables, lack of random assignment, no control groups, not accounting for teacher influence, and very little systematic investigation into what makes one map better than another.
And limitations of the map systems themselves.
Yeah, many only used one or two of those three signaling devices: layout, nodes, lengths. Lack of awareness about how visual spatial properties affect processing ease and computational efficiency.
Right.
Limited node types. And the crucial role of links often wasn't fully leveraged. Relationships left unspecified, ambiguous, mostly idiosyncratic labels. Also, not much thought given to the underlying knowledge structures being mapped, or direct comparisons between different map types conveying the same info. Overall, most approaches lacked systematic theory-based development.
That really sets the stage for the TCU system then, which they argue was more systematic. Tell us about their research and refinement process.
Right. The TCU system had been continuously developed for over 15 years at that point, based on their own theory and findings and others' work.
Okay.
Their initial framework assumed effective map use requires integrating both spatial and verbal processing. Drawing on theories from statistical graphs, geographical maps, picture-text processing, text comprehension, spatial cognition. Figure 17 illustrates this model.
So when we look at a map, both the visual spatial brain parts and the language parts are involved.
That's the core idea, a dual system model. Similar to theories for other visual verbal info processing. These systems work somewhat independently, but interact through three overlapping stages: comprehension, encoding storage, and retrieval utilization.
Okay, let's break down those stages. Comprehension.
During comprehension, the spatial system quickly gives you an initial sense of the map complexity, balance, gaps based on Gestalt principles, visual cues. This meta-knowledge then guides verbal processing, attention allocation, questions, importance, judgments.
But a potential weakness.
Yeah, we don't necessarily have an automatic scanning strategy for maps like we do for linear text. Could lead to haphazard processing, skipping bits.
Okay. And encoding and storage, how does that work?
Verbal processing refines the structural info from the map into a relatively lasting spatial image in our minds.
A mental map.
Exactly. This serves as a framework for integrating new info, manipulating the verbal ideas, moving from just remembering text to a deeper, connected understanding.
Potential drawback here.
The strong visual input from the map might actually interfere with forming other mental imagery related to the content. Brooks' suppression effect.
Interesting. And finally, retrieval and use.
During retrieval, that mental map image provides quick access. Spatial and vodal systems cross-cue each other, making recall more efficient.
Potential weaknesses here too.
If different subjects have similar abstract map structures, could cause interference. And if your overall mental map is distorted, it could mess up recalling specific details within it.
This framework seems valuable for understanding why some maps work better than others. What kind of research did the TCU group actually do?
Early work focused on training college students to make maps from text lectures, networking, they called it. Found it was good for summarizing, led to better delayed recall than traditional methods. But big differences in the quality of student maps even after training. So they shifted focus to using maps created by experts.
Okay.
More recent research used these expert maps, varying topic size, type, abstraction, layout, as supplements or replacements for text and lectures with undergrads. Assess learning via delayed recall, satisfaction questionnaires, processing questionnaires.
And what were some key findings from that research using the expert maps?
Okay, some highlights. Even brief map exposure led to better meta-knowledge study time budgeting, recall prediction, than brief text exposure. Procedural maps, showing processes, seemed more effective than conceptual hierarchies, possibly because the processing route was clearer visually.
Sequence versus category.
Right. And generally, procedural maps beat text counterparts, especially for main ideas and structure. Visually prominent parts were recalled better.
Okay.
Interestingly, some evidence maps might slightly inhibit processing-related pictures. maybe competing for spatial processing resources.
Ah, that interference idea again.
Yeah. Also, students with low prior knowledge benefited greatly from maps during lectures, and maps seem to help cooperation among high verbal ability students.
So promising evidence maps can really help in certain situations.
Definitely looks that way.
Yeah.
Valuable tools.
What were the TCU researchers working on then, and what did they see as the future?
They were continuing to investigate when student map creation is better versus expert map provision. Also digging deeper into map parameters layout, node info, link explicitness, and how they affect search, recognition, inference.
Fine-tuning the map design.
Exactly. They acknowledged the TCE system was ready for use, but expected it to keep evolving. Future vision included exploring maps with different populations, individual differences, adapting maps to diverse subjects.
They had plans.
Yeah, even envisioning atlases of knowledge replacing textbooks and integration with new tech like video discs, holograms.
Wow, looking quite far ahead back in '89.
They certainly were.
Well, this has been a truly insightful deep dive into multi-relational semantic maps. For you, the learner, the key takeaways seem to be: these maps offer a structured visual way to grasp complex info by showing connections clearly.
Systems like TCU provide a detailed framework, visual cues, organizational strategies designed to boost understanding.
And while research is ongoing, there's compelling evidence they can significantly improve learning, especially for grasping main ideas, understanding structure.
And maybe even making your learning more efficient.
Exactly. And for your specific interest in efficient learning, this look at knowledge maps offers a potential shortcut, right? A way to see connections and the bigger picture without feeling overwhelmed by linear text.
Yeah, a really promising approach.
So here's a final thought for you to consider. Could actively incorporating visual mapping techniques into your own learning or work, could that be the key to unlocking deeper understanding and managing information overload more effectively? What kind of topics would you be most curious to map out and explore this way?